Hi everyone! In this video, I will show you some examples on how I deal with word problems involving factors of polynomials. So, let's start solving these problems. The product of two consecutive integers is 210. Find the integers. First, define your variables. In our example, we are asked to find consecutive integers whose product is 210. Again, we are looking for consecutive integers. So we will have n as the first integer, then add 1 unit to the first integer to get the second integer, and that is n plus 1. The operation of the integer is product. So we will multiply the two integer and their product is 210. Let's now substitute the values of each integer to the formula we formed, and that is n times n plus 1 equals 210. N times n equals n squared. N times 1 is n. So we will have n squared plus n equals 210. In our case, we have to use additive inverse property to transform it in standard form. Additive inverse of 210 is a number that when you add to 210, it gives us 0. That is only the opposite sign of the number. Opposite sign of positive 210 is negative 210, and we will add that on both sides of equals. So we will have n squared plus n minus 210 equals 210 minus 210. Simplify, so we have n squared plus n minus 210 equals 0. In getting the factors of the polynomials, we must check if the given has GCF, then check if the given is written in standard form. We will now factor the polynomial factors of negative 210 whose sum is positive 1. So we have positive 15 and negative 14. So we have n plus 15 and n minus 14 equals 0. Equate each factor to 0. So we have n plus 15 equals 0 and n minus 14 equals 0. Then use additive inverse again to get the value of the first integer. So we have inverse of positive 15 is negative 15. N plus 15 minus 15 equals 0 minus 15. So we have the first value of n is negative 15. What about the second factor? We have n minus 14. Additive of negative 14 is positive 14. And then simplify. So we have the second value of n as positive 14. Therefore, if n is negative 15, then the second integer is n plus 1, or negative 15 plus 1 equals negative 14. Therefore, the two integers are negative 15 and negative 14. For the second value, if n is 14, then the second integer is n plus 1, or 14 plus 1 equals 15. Therefore, the two integers are 14 and 15. Another example, the sum of a number and its square is 156. Find the numbers. First, define your variables. In our second example, we are asked to find two numbers whose sum is 156. So we will have n as the first number, then square the first number to get the second integer, and that is n squared. The operation of the integers is addition. So we will add the two numbers and their sum is 156. Let's now substitute the values of each integer to the formula we formed. That is n plus n squared equals 156. In our case, we have to use additive inverse again. Opposite of positive 156 is negative 156. So we will add on both sides negative 156. So we will have n squared plus n minus 156 equals 156 minus 156. Simplify the polynomial. So we will have n squared plus n minus 156. N squared plus n minus 156 equals 0. We will now factor the polynomial. Factors of 156 whose sum is positive 1. So we have positive 13 and negative 12. When we multiply positive 13 and negative 12, it will give us negative 156. But when we add the two factors of negative 156, it will give us positive 1, which is the middle term of the given polynomial. Then equate each factor to 0. Again, use additive inverse to get the value of the first integer. So we have opposite of positive 13 is negative 13. N plus 13 minus 13 equals 0 minus 13. Simplify. So we have n equals negative 13. The first value of n is negative 13. What about the second factor? Opposite of negative 12 is positive 12. So we will add on both sides positive 12 and then simplify. So we will have the second value of n is positive 12. So if n is negative 13 and the square of it is 169, then n plus n squared equals 156, or negative 13 plus 169 equals 156. Therefore, the numbers are negative 13 and 169. Or, if n is 12 and the square of it is 144, then n plus n squared equals 156, or 12 plus 144 equals 156. Therefore, the numbers are 12 and 144. Another example, the height of a triangle is 2 millimeters less than the base. If the area is 60 millimeters squared, find the height and base of the triangle. Remember that the area of a triangle is area of any triangle equals 1/2 base times height. Let us now define our variables. Let b equals base. Let height equals b minus 2. Let's now substitute the values of each integer to the formula we formed. Area of the triangle is 60. 1/2. Our base is b. Our height is b minus 2. And then, let us multiply both sides to positive 2. 2 times 60 is 120. 1/2 times 2. So we will cancel them. The remaining terms are b times b minus 2. And then simplify. We have to apply distributive property. We will distribute b to b minus 2. So, b times b is b squared. And then, negative 2 times b is negative 2b. So, we will have 120 equals b squared minus 2b. We will use additive inverse again. Opposite of positive 120 is negative 120. So we will add the opposite of 120, and that will be negative 120 plus 120 equals b squared minus 2b minus 120. Simplify, so we will have 0 equals b squared minus 2b minus 120. And then factors of negative 120 whose sum will give us negative 2. So we will have 0 equals b plus 10 times b minus 12. Let us equate both factors to 0. So we have b plus 10 equals 0. b minus 12 equals 0. And then, use additive inverse. Opposite of positive 10 is negative 10. So we have b plus 10 minus 10 equals 0 minus 10. b plus 10 minus 10 equals 0 minus 10. Simplify, so we will have b equals negative 10. Another factor, we have b minus 12. Opposite of negative 12 is positive 12. So we will have b minus 12 plus 12 equals 0 plus 12. Simplify, so we will have b equals 12. We will only accept positive 12. We cannot accept negative integers in real-life situations. Therefore, if the base of a triangle is positive 12, then its height is b minus 2, or 12 minus 2 is 10. Therefore, the base is positive 12 and the height is positive 10. Let us have another example. The product of two consecutive integers is 272. Find the value of each integer. Let us define the variables. Let n be the first integer, and the second integer is n plus 1 because we are finding two consecutive integers. So the product of the first and second integer is 272. Our first integer is n, second is n plus 1. Substitute the values, so we have n times n plus 1 equals 272. Simplify by distributing n to n plus 1, so we will have n squared plus n equals 272. Apply the additive inverse property, or the opposite of positive 272 is negative 272. So we will add on both sides and then simplify. So we have n squared plus n minus 272. Factors of negative 272 whose sum is positive 1. So we have n plus 17 times n minus 16 equals 0. Equate each factor to 0. So we have n plus 17 equals 0 and n minus 16 equals 0. Use additive inverse property. Opposite of positive 17 is negative 17. So we have n plus 17 minus 17 equals 0 minus 17. Simplify, so we will have n equals negative 17. The second factor, we have n minus 16 equals 0. Let us have additive inverse property. Opposite of negative 16 is positive 16. So add on both sides. Simplify, so we have n equals positive 16. So if n is negative 17, then the second integer is n plus 1, or negative 17 plus 1 equals negative 16. Therefore, the two integers are negative 17 and negative 16. And if n is positive 16, then the second integer is n plus 1, or 16 plus 1 equals 17. Therefore, the two integers are positive 16 and positive 17. Another example, the product of two consecutive integers is 528. Find the value of each integer. Let us define our variables. Let n be the first integer and n plus 2 is the second integer. Again, we are talking about two consecutive even integers. Our operation must be multiplication. So we have first integer times second integer equals 528. First integer is n, second integer is n plus 2 equals 528. And then use the distributive property, so we have n squared plus 2n equals 528. Let us have additive inverse property. Opposite of 528 is negative 528. We will add that on both sides and then simplify. So we have n squared plus 2n minus 528. Factors of negative 528 whose sum is positive 2. So we will have n plus 24 times n minus 22 equals 0. Equate each factor to 0. So we have n plus 24 equals 0. N minus 22 equals 0. And then use the additive inverse. Opposite of positive 24 is negative 24. We will add negative 24 on both sides and then simplify. So we have first value of the first integer is negative 24. Let us have the second. Opposite of negative 22 is positive 22. So we will add on both sides positive 22 and then simplify. We have n equals positive 22. So, if n is negative 24, then the second integer is n plus 2, or negative 24 plus 2 equals negative 22. Therefore, the two integers are negative 24 and negative 22. And if n is positive 22, then the second integer is n plus 2, or 22 plus 2 equals 24. Therefore, the two integers are 22 and 24. Let us have our last example. A rectangular swimming pool is twice as long as it is wide. A small concrete walkway surrounds the pool. The walkway is a constant 2 feet wide and has an area of 196 square feet. Find the dimensions of the pool. The first thing you need to do is to define your variables. In this example, the length is described in terms of the width, so define the width. Let W be the width of the pool. The problem says that the length is twice as long as the width. And remember that twice means to multiply by 2. Let 2W be the length of the pool. This means that the area of the pool is W times 2W. The pool has a concrete walkway of 2 feet surrounding it, so this means that there is 2 feet on each side of the width and the length. So we need to increase both of the length and the width by 4 in order to get the length and the width of the pool and the walkway. This means that the width is W plus 4 and the length is 2W plus 4. In this case, we have two areas. We have the area of the pool and the area of the walkway and pool. So we will have total area equals walkway and pool area minus the area of the pool. In order to find dimensions, we need to use the two different areas. So let us now substitute the values to our formula. Total area given is 196. The area, walkway, and pool is W plus 4 times 2W plus 4 minus pool area is W times 2W. Let us simplify. So we will have 2W squared plus 4W plus 8W plus 16 minus 2W squared. Add similar terms. So we have similar terms are 2W squared and 4W plus 8W. So we will cancel 2W squared because they have different signs. And then 4W and 8W add, copy 16. So we will have 196 equals 12W plus 16. And then let us use the additive inverse. So we will have the opposite of positive 16 is negative 16. So 196 minus 16 equals 12W plus 16 minus 16. Simplify. So we will have 180 equals 12W. Then divide both sides by 12. So we will have 180 divided by 12 is 15. Therefore, our width is 15 feet, but we aren't done yet. The question asks for the dimensions, so we still need to find the length. The length is twice the width. So 2 times 15 is 30 feet. Therefore, the dimensions of the pool are 15 feet by 30 feet. I hope you learned a lot in this topic. Practice more in factoring, and we will see again on my next video. Thank you for learning with me. Bye!